Welcome to our 11.4 lesson. Our essential question for 11.4 that we'll be exploring as we go through our videos is, why does the way in which data are spread out matter? So hopefully we'll have an answer to that after we go through our different videos here. So in 11.4, we are going to focus on something called standard deviation. This is about to get very mathematical and technical, so just bear with me and know that our following videos will help make sense of some of this. So in Word, standard deviation is a measure of spread or variability. It indicates by how much the values in a data set deviate from the mean. So we know the mean is the average. So how much do the values deviate from the mean? All right. Here's where we get technical. It's the square root of the variance. So there's a new word. What is the variance? The variance is the average of the squared deviations from the mean. When data are normally distributed, so that is, we're going to see things, you're going to see that again, that normal distribution. So when data are normally distributed in a bell curve, the mean and the standard deviation describe the data set completely. So standard deviation is a pretty big descriptor of data sets in statistics, and so we're going to explore that in this lesson. So the algebra of what standard deviation is, you get to see kind of some new symbols here. So it is if you're finding the standard deviation of a sample, so let's say you sampled 30, whatever it is, that's your sample size. We have S for standard deviation equals, we've got this big square root of, now this E, looks like an E, that stands for the sum. So that means you're going to add together whatever it is that is following that. So let me zoom in a little bit. It's a little blurry, I apologize for that, but what we're doing is we're taking the data value and we're subtracting this X with a bar over it. Why don't we go ahead and make sure we define that? Anytime you see that notation, that's what the mean is. So if you have to say, refer to the mean in any way, X with a bar across the top is what we know to use to represent the mean. So what it's saying is we take each data value, subtract it from the mean, and we square it. When we square it, we will get positive values, and then we add all those together. We're going to divide that by n is the number of data in the sample minus 1, and then we square root that whole thing. Over here, standard deviation of a population. So if we're talking of a population versus a smaller sample size, the only difference is we're dividing by n instead of dividing by n minus 1. So this sounds exciting, doesn't it? Look what we get to explore in this lesson. So here's a diagram of a normal distribution. We also would call this a normal bell curve. That was in the definition above. So what you can see is in the middle is where the mean is. And we can tell that this is symmetrical about the mean. We've got it going off to the left, right, off to the left. And we can divide whatever it is, whatever our data is representing, into these segments if it has a normal distribution or there's a normal bell curve. One thing you could think about is, let's say, IQ. We're familiar with IQ tests. The mean would be the average. So a lot of people are going to just have an average IQ. That would be in the center here. So this 34.1% to the right and 34.1% to the left, that gives us a total of 68.2% of people fall within this region right here, where you're closest to the average. So most people, 68.2% of people, would fall into this region. Now, as it trails off to the right, you're going to get smaller percentages of people that have, in this case, higher IQs. So here at the tail at the very end, there's not a lot of people that have extremely high IQs. So that's going to be a very small percent of people. As it trails off to the left, we get really small again. There's not a lot of people that have extremely low IQs, and that's where those people would fall. And so, how many standard deviations are we talking about away from the mean? We divide it into these percentages. You're going to see these again: 34.1, 13.6, 2.1. So, if you go one standard deviation away from the mean in the positive or the negative direction, you're kind of talking about 34.1% of the people, and I'm just using people's IQs in this example, are either above or below. If you're two standard deviations away, that just kind of tells you how far away you are from the mean. Just in general. We'll get into specifics in our following videos.